Hi there, in this video we'll be learning how to find out the length area of the volume by using the similar shapes. So to begin with the first thing, the length of the scale factor. So we say that the length of the scale factor is A. To find out the area scale factor, we do the square of the scale factor, the length scale factor. To find out the volume, we do the cube of the length scale factor. So in other words, I can even write it down as this is the length scale factor. So that's the length scale factor. This is the area scale factor. And the third one is the volume scale factor. So if you're going in the forward direction, like let's say you're going from the length scale factor to the area scale factor, what you do is the square. If you're doing from the length scale factor to the volume scale factor, you do the cubing of it. So going in this direction would be that. But let's say if you're coming in the backward direction from the area scale factor to the length scale factor, so rather if you're doing the square, now you do the square root. To go from the volume scale factor to find out what the length scale factor is, you do the cube root. Now we'll be using this further to do the question. So here we have got the first exam question, and in the first exam question this says that the two cones are mathematically similar to each other. So they are mathematically similar to each other. So if the radius of the smaller cone is 3 centimeter, work out the radius of the larger cone. So I'm going to write down that we have been given the radius of the smaller cone, which is r equals to 3 centimeter, and we are finding out the radius of the bigger cone which we are looking for. The first thing we always do is to find out the scale factor. So I'm writing it down over here. The first thing we are finding out is the length scale factor. To find out the length scale factor, you do the bigger length divided by the smaller one. So that would be 9 divided by 6 would be 1.5. Once you would have the scale factor, then after that, what you're going to do is you find out the radius of the bigger one. So remember that whenever we are going from the smaller to bigger, so we are going from the smaller to the bigger in this direction, then we always times by the scale factor. But if we are going from the bigger to the smaller, we divide by the scale factor. So it is very important for you to remember that if you're going from smaller to bigger is times, when you go from bigger to smaller would be divide. We know that what's the radius of the smaller cone, and we are finding out what's the radius of the bigger cone. So what we're going to do this time is the multiply. So to find out the radius of the bigger cone, so I'm going to write down radius of the bigger cone. We are finding this out. So to find out the radius of the bigger cone, you're going to do whatever the radius of the smaller cone is, which is 3. You multiply it with the scale factor, which is 1.5. When you do 3 times 1.5, you get 4.5 centimeter, and that's the radius of the bigger cone. To do the part B now, which is what we are finding out is if the surface area of the smaller cone is this, work out the surface area of the larger cone. Again, in this situation also, we are going from the smaller to the bigger one, but this time it's to do with the surface area. So what we do is, when we know what's the length scale factor, to find out the area scale factor, what we do is we do the squaring of the length scale factor. So from here we know that the length scale factor is a 1.5. To find out the area scale factor, you do 1.5 square. 1.5 square is same as doing 1.5 times 1.5, and that would give 2.25. This is the area scale factor. Now, because we know what's the area of the smaller cone and we are finding out the area of the bigger cone, so I'm going to write it down. We are finding out the area of the larger cone. So you do that, what's the area of the smaller cone is 64, and you times by the area scale factor, which is 2.25. So to find out the area of the larger cone, when you multiply them together, you will come out with 144, and the unit would be centimeter square. To do the part C now, in the part C, this says that if the volume of the bigger cone is 324. This time now, the bigger one is given to us and we are finding out the smaller one. So we're going to divide the scale factor with and work out the volume of the smaller cone. So now we are finding out the part C, which is to find out the volume of the smaller cone. So to find out the volume of the smaller cone, the first thing we need to find out is the volume scale factor. So the volume scale factor would be when you do the cubing of the length scale factor. So that would be 1.5 power 3. 1.5 power 3 is 3.375. So that's the volume scale factor. Once you would know what the volume scale factor is, now you're finding out the volume of the smaller cone. So you do the volume of the bigger cone, which is 324. I'm going to write it down here. 324 divided by the scale factor, which is 3.375. And when you divide them together, you get 96 centimeter cube is going to be the volume of the smaller cone. Now here we have got like a shape given, and this says that is a trapezium. So now the information given to that is AEFG has an area of 36. So first I'm going to see that what is that area AEFG. So if I draw it, AEFG is 36. So we know the area of the smaller trapezium, and this says that work out the area of the shaded region. So it's very clear that to find out the area of the shaded region, it would be area of the big trapezium minus the area of the smaller trapezium. Okay, so we know the area of the trapezium. The smaller trapezium is known to us already, which is 36, and I'm going to write down this part is 36. What we need to find out is the area of the big trapezium first of all, and we're going to take away them together. So on the top, on the side, I'm finding out the area of the big trapezium, and the big trapezium is A, B, C, D. So I'm going to write down A, B, C, and D. Now, what we know that is, what's the scale factor is. So first we're going to start with the length scale factor. So because we know that this is 12 and this is 18, I can find out the length scale factor by dividing them together. So to find out this thing, the first thing we are doing is to find out the length scale factor, which is going to be 18 divided by 12. And when you're going to do 18 divided by 12, you get the length scale factor, which would be 1.5. Once you would have that 1.5, now you're going to find out the area scale factor. So that would be the squaring of the length scale factor. So area scale factor would be 1.5 square. And when you do the square of 1.5, you'll get 2.25. So this is your area scale factor. Now we know what the area scale factor is, and we are finding out the area of the bigger shape. So because we are going from the smaller to the bigger, so we multiply by the scale factor. So what we're going to do is now we are finding out the area of ABCD, which is the area of the small trapezium, which is 36 times by the area scale factor, which is 2.25. To find it out, you're going to get, it would be 81 centimeters square. Now, because we are finding out the area of the shaded region, so area of the bigger trapezium, which we just found is 81, you minus 36 from it, that would be the area of the shaded region. So now you write it down, area of the shaded region would be, that would be 5, 8 take away 3 is a 5 again. So that would be 55 centimeters square. That would be the area of the shaded region. Now here we have got the next example now. So this is that the two pyramids A and B are similar to each other. The surface area of the pyramid A is 1260. So this pyramid has got the surface area of 1260. I'm going to write it down here. This is for the bigger one, A. Now the surface area of B is, I'm going to change this to B, and the surface area of the B is 180. So I'm going to write down surface area of the next one is 180. The volume of A is, so now what else is given to us, that the volume is 9604, and we are finding out the volume of B. So we are finding out the volume of the smaller one. What we're going to do is now, with the given information, you can even do it by making a table as well. This is sometimes really easy for the students to understand. So we have got the shape A and B. What the given information is, this is the length. We don't have anything about the length. Then the next is the surface area, and the next is the volume. So the surface area of the shape A is 1260. I'm going to write this down here. The surface area of the shape B, because it's smaller, it's 180. The volume is 9604, and the volume of this, we are finding it out. I'm going to make an additional column of the scale factor. We don't know what the scale factor is. So what the two things are given to us is about the surface area. So I'm going to find out the scale factor of the surface area. So I'm going to write down area scale factor. So to find out the area scale factor, you do the bigger, which is 1260, divide by 180. And you're going to get the scale factor, which is 7. So we know that this scale factor is 7. Now, what we have to find out is the volume. So it means we need to find out what's the volume scale factor is. But we cannot find out the volume scale factor directly. First, we're going to find out the length scale factor. So length scale factor is basically when you're going from the area to the length, you do the square root. That would be root 7. Once you know what the length scale factor is and you're finding out the volume scale factor, which means that you're going to do the cubing of it. So to find out from the length to the volume, I'm making a direction. That would be the cubing of it. That would be 7 root 7. Now we know what's the volume of A, and we know what's the scale factor or volume scale factor is. By using that, we're going to find out the volume of the shape B. So I'm going to write down what we are finding as the volume of B. Because we are going from the bigger to the smaller one, so this time we're going to divide. So we're going to write down 9604 divided by 7 root 7, which is the volume scale factor. And when you're going to do that, you're going to come out with 518.57, which is estimated to 519. And the unit we see that is a centimeter cube. So here we have found out the volume of the pyramid B. Here we have got the last question. Now this is the exam question. This is actually a challenging question. So we're going to do that step by step, and we'll see that how we'll be able to get all the information to find out the final thing. So here we see that there is a big cone given. This is that a frustum is made up of by removing the smaller cone from a similar larger cone. So this part is basically is a frustum, where you remove the smaller cone from the top of the bigger one. So now the height of the smaller cone is 20. It is always easy that you're going to draw the shape separately. So this is the smaller cone, and I'm going to draw on the side is the bigger cone. The given information says that the height of the smaller cone is 20. So this is 20 centimeter here. The height of the bigger cone is 40. So I'm going to write down it's a 40 centimeter here. Once you have got the height of the smaller and the bigger one, what you'll be doing is you'll be doing further to find out what you can see. So now the diameter of the base of the larger cone is 30. So this is a diameter which is 30. So this whole thing is a 30 centimeter. Now we're going to see that how much is the radius would be the half of it, which would be 15. So I can say that the radius of this one would be 15 centimeter. The next part of the information says that work out the volume of the frustum. So we are finding out the volume of the frustum, which the shade this is the volume we are finding out of the highlighted region. Give your answer to the three significant figures. So what we are doing is basically we find out the volume of the bigger cone. So we're going to find out the volume of the bigger cone, and from that when we minus the volume of the smaller cone, we're going to find out the volume of frustum. Okay, I'm going to start by finding out the volume of the bigger cone. The first thing I'm going to do is to find out the length scale factor, because we know the height of the bigger and the smaller cone. So I'm going to find out the length scale factor, which you get the bigger divided by the smaller, which is 40 divided by 20 would be 2. Once we would know that what's the length scale factor is, we can even find out the volume scale factor as well, because we'll be finding out the volume. So the volume scale factor would be the cubing of it, which would be 8. Now what we find out is we're going to find out the volume of the bigger cone. So to find out the volume of the bigger cone, we have a formula, a third pi r square h. So when you sub in a third pi r square h, you'll get the volume of the bigger cone. So I'm going to find it out. It would be 1/3 pi. What's the radius is? Radius is 15 square and the height is 40. So once you sub in everything into here, you're going to get 3000 pi. So that's going to be the volume of the bigger cone. To find out the volume of because they both are similar to each other, and to find out the volume of the smaller cone, what you have to do is you're going to divide the volume of the bigger cone, which is 3000 pi, divide by the scale factor, which is 8. And when you divide them together, you're going to get the volume that would be 375 pi. So 375 pi would be the volume of the smaller cone. To get now the last part, which is to find out the volume of the frustum. So I'm going to write down the volume of frustum would be the volume of the bigger minus smaller. So I'm going to write down volume of the bigger minus the volume of smaller one. So because we know that the volume of the bigger is 3000 pi, we know that the volume of the smaller is 375 pi. You take away them together, and because this says that you have to give your answer to three significant figure, you're going to come out with the whole thing would be 8246.68. This is not the three significant figure. So your final answer would be to writing it down in the three significant figure, and that would be 8250. So that would be the volume of the frustum. Because we know that the unit is a centimeter, the volume would be centimeter cubed then. So here's the whole explanation of how to find out the scale factor of the length, area and the volume. And using the scale factor, how can you find out the length of the, or the area of the, or the volume of the required region, what they're asking you to find out in the question. So I hope you have found this video useful, and please don't forget to subscribe my channel so you'll be updated with more videos then. Thank you.